A very good morning to all the participants. We have had a very interesting set of presentations bringing perspective from different dimensions of this entire landscape of RE, from OEM side, from the plant level, integration and related aspects, and then the grid side aspects. Unfortunately, due to some traffic delay, the other speaker could not actually reach the venue on time for the presentation, but he is joining us soon in the panel discussion. So, taking forward the discussion that we have had through these two interesting presentations, we already saw that there are several challenges that we currently are experiencing with this integration. And as yesterday I mentioned it and other speakers also highlighted, that these new challenges with more and more penetration of renewables are not something new and unique to Indian grid. So they have been there, they are there, and they will be there. New and emerging challenges will actually emerge as we move forward in this journey. But the main point is that how do we sail through this transition of the power sector, particularly the grid, from the conventional based synchronous power plant based system, which has been running relatively very nicely because of these inherent grid support characteristics of the conventional generators, and then how do we effectively integrate these renewables in a constructive and collaborative manner with the support and cooperation from all the stakeholders. So we have a target of 2030 and beyond. So therefore, so we looking at the current issues that we have with the grid and how the grid operator is trying to address those issues with the renewable energy integration. We are integrating more and more as we move forward, and 2030 target is in front of us, and then beyond also we have to go. So therefore, there are certainly going to be the challenges with integration of the renewables further, and we need to, all the stakeholders need to actually contribute to address those issues and see how seamless integration of renewables is achieved in the country. So, I will. The format of this panel discussion is I'll be asking some specific questions to each of the panelists, but I'll also open up in between for some questions from the audience as we move forward in this discussion. So my first question is to Mr. Bernhard. You, as you also pointed out in your presentation, you have experience over different countries across the world in integrating, in putting up your wind turbines and other solutions that you also mentioned, power plant controller and other related, smart solutions that you have developed in Switzerland. So, in comparison to these countries such as Europe, Australia, or other countries that you have been, putting up wind turbines, what are your expectations, recommendations, for Indian grid authorities with respect to this connection of wind turbine generators at large scale?
Yeah, thanks for Zakir. Thanks for the question. And first of all, I have to say, very impressed about the presentation of Vivek. I mean, that's exactly what also my answer will lead to. What do we have already? What do we know? Where are case studies being done? And if you compare a little bit, let's go into the history about this grid codes, because it's about playing together. So there are roots. Yeah, let's go back. What was since 2013? We have this LVRT, right through clauses in the grid. Whatever details we are, but that's so. Then since 2019, yeah, HVT requirements come. Yeah, so another involving. So it goes on. Yeah, and then the power quality aspects came in. DC injection things, frequency drops. You manage that right through more carefully. And if we see this package, yeah, I mean, if you fulfill that as an OEM, as a partner in the grid, yeah, I think you're more than half done. So I think it is also, and I got the smell from you, it is about really, we have a lot of regulations, prove what is required. Because the technology behind can do that. At least from a wind turbine perspective, yeah, because we have not the full frequency controllers using, we have a double feed arrangement, so there are capabilities. And then of course you have the other playing grounds of capacitor banks, STATCOMs, yeah, and look at Australia or South Africa, yeah, where you started with single grids, yeah, and huge events. So also they developed their tools, they managed it, and that's what we're doing also in India, going forward. But of course, we are at 20% electric power. We want to go up, we want to double, and that really, at every single connecting point, requires a clear understanding of what can be done by the RE part, what can be done by the grid.
Thank you, Mr. Bernhard. So interesting. We can address these different issues. Moving forward, Mr. 𝗏𝗶𝗍, sorry we could not have you for the presentation, but I'm glad that you are here for the panel discussion. In this entire ecosystem of RE, we have different stakeholders, and of course, for the fact that there are different conflicting interests of different stakeholders, and RE developer is one of the key stakeholders of this entire ecosystem. In your opinion, based on your own experience from Renew and others, other RE developers, what are the key challenges or issues that you as an RE developer are currently experiencing in the journey of this developing and putting up the renewable energy plants in India?
Apologies for being late. Will I be getting the opportunity to make the presentation, or should I cover my presentation material in the discussion itself?
Unfortunately, we will not have no time to have the presentation, so you can try to cover.
Yeah. So, if you want to talk about the challenges for RE developers, then there's so many, right? And if we wanted to, you wanted me to confine it to grid.
Key challenges preferably related to the topic grid integration.
So, broadly means like if we are deploying solar, we have issues around land, right, ROW and all that, right? So I don't want to get into all that, especially with respect to this grid integration. So if you see the way it was happening before, and post that working committee recommendation, things have changed completely. So that report itself kind of changed the way we had been working earlier, right? And there were so many requirements which was put on the developers to adhere to, and they were very, very onerous, right? Just to give an example, because CA regulation for connectivity was existing from 2007-8, right? And there were some amendments in between. Now, one fine evening, means like, that working committee report, we got this mandate that you have to ensure reactive power compensation in your plant, right? We don't have any issue. But suppose a plant that I have deployed in 2015-16, right? And that, at that point of time, we were not going for that kind of, very precise modeling of PSCAD, PSSC and all that. And if you wanted me to do those kind of compensation arrangement, it's next to impossible, because there is no land, there is no, the inverter supplier, some of the inverter make have already become obsolete, right? Now, that's why we fought. And there was, since it was a working committee recommendation, right? It was not a regulation. We were not entitled for change in law also. We fought it, we are fighting it in CERC. And so there are so many asks So I just took one example, right? So I believe that RE per se is over-regulated. There are so many regulations that we need to abide by. Apart from working committee recommendation, we changed our grid code in October 2023. Then all, inform power and all those regulations which came into picture. Then DSM regulations. In last 3 years, DSM regulation have been changed thrice. And every time the band is squeezing, right? And when these regulations are changing, it's not for the projects which we are going to deploy in future so that we can account for their financial implication in our tendering or biddings, etc. So it's all a loss in our, so it's basically reduces the financial viability of the projects, right? And in the eyes of the lenders, it's a big hit, right? I'll give us one very interesting example that I'd like to share. You said, and I just missed the presentation and opportunity, that all the WTGs in the country, that should be designed for the ambient temperature, right? Ambient temperature, and we discussed it, and ambient temperature, if we wanted to deploy in Rajasthan, in Jaisalmer, the ambient temperature was 50.2 degree, right? So if we wanted to have any WTG in Rajasthan, it should be designed for a temperature of 51 degree. It should be capable of giving the rated capacity at a temperature of 51 degree. There was no WTG available at that point of time in the country. So while you are making that regulation, you should be a bit pragmatic also. You should see how it will get implemented in the country. Then we discussed with Vivek, was also a participant in that, and I know he is going to counter me, but let's have a very honest discussion, right? We started running from pillar to post. A lot of people have already tied up with WTG manufacturers, and we ran to the ministry. Finally, as per the IEC, it was decided that the operating range of the WTG as per IEC is -10 to 40 degree. So any turbine which is not derating below 40 degree, that should be allowed. That was decided by the ministry. So see, means in technical discussion where we are developers having a lot of, Grid India, CTU, everyone is there. But the final adjudication is being done by a person who is a bureaucrat. And he is deciding, okay, chalo, means like we are kind of bargaining that 40 degrees should be fine, okay, so let's adopt that IEC. And so these kind of challenges, and now we are adopting it. Still, there are some WTGs by very, very renowned manufacturers which start derating beyond 36, 37. They have deployed in past, but now they are not being able to get contracts in the country. So what I mean to say that there are a lot of issues around, and since we are the actual doers on the ground, so policymakers and academia like you should be cognizant of the fact that there are a lot of challenges. I wanted to do it. You tell me how I can do it, right? You wanted me to do the modeling, PSCAD, PSSC. There are so many complex modelings which are coming up. Right now, till now, we had only plain vanilla solar, plain vanilla wind, right? Now we are getting into FDRE, firm and dispatchable RE kind of tenders, where at a single location we are going to have solar, wind, battery, everything, right? So all these modelings are going to get very, very complex. And all of us are learning in the process. But we are always at the receiving end. I wanted to go for the best of the forecasting and scheduling. You tell me how I can do it. There is no way. And why are you punishing the developers only? So there is a need to kind of develop an ecosystem where all of us should participate in this, improvement of, because it's a learning process, it's a evolution which will happen in the days to come, right? So there are so many challenges that we face, and right now, if you ask any developer, CON4 approval, FTC, commissioning, trial run, all these are nightmare for the developers. and they are running to to the CTUs, to that pressure course, and pleading, kind of cajoling. Sometimes, sir, I can do this much only. Please see. So all those things are happening, right? Because the requirements which are being asked, sometimes we are in a position to meet, sometimes we are not. So what should I do? You tell me, how can I meet your requirement? So these are some of the points that I capture. Maybe that we can come for the next question then.
Thank you. I understand that. That's why I started with my comment that the different stakeholders have, diverging interests, and then bringing them together and making them cooperate and achieve this entire goal of integrating renewables in a collaborative manner is essential. I understand that regulations do have financial and commercial implications on different stakeholders, and some of them you highlighted, and that was the purpose that we have OEM, developer, and the grid operator on the same platform to actually understand the challenges and the concerns that they have, from their perspective, and see how we can actually together in a collaborative manner understand and find a solution together for the challenges and the issues that each of the stakeholders is actually going through. So this is a journey, and I think it has to be a journey together from all stakeholders. Vivek ji, so I requested Chaubey ji to tell his concerns and his challenges. So similarly, we are from the academics. We are fortunate to see the challenges and issues from all the stakeholders. We do interact with the different stakeholders. So you also have those different challenges. Some of the pain points you already highlighted in your presentation. How difficult it is to manage the grid and all that. So what are your in your opinion the key challenges that you as a grid operator are experiencing in handling these renewables? And as I mentioned in the beginning, we'll have more and more renewables. This is just initial phase of this journey of integrating renewables. And what are your expectations from these different stakeholders of this ecosystem?
Yes, thank you, sir, for that question. Before I answer to that question, there is one remark, and I think we all need to acknowledge and accept it, that electricity is one of the most, in fact, perfectly non-discriminatory. Human beings can be discriminatory, biased, but grid and electricity is perfectly non-discriminatory. If the physics wants something, it has to be done. It doesn't recognize whether commercials are involved, whether tendering is involved. If something has to be set right, it has to be set right. So that's the fact of the matter. And you have very rightly sandwiched me between.
That's why I'm on the
But I take a look at something positive, that the academicians and the R&D guy is on my right hand. So they'll support this development, and I acknowledge that yes, there are challenges, and that's the reason why we have been adopting a slightly relaxed approach. And if we strictly go by what is written in the standard, then of course there are interpretations and a lot of issues. So this via media or negotiation or discussion has been introduced. So the challenges I have already highlighted, that we started, RE was small, we treated it with kids gloves and all that. But then now RE has grown up and it's in its teenage phase, and those teenage tantrums are visible, and it has to be disciplined, and some give and take will be there. We'll say, okay, we'll do some operational strategy or protocol or something to accommodate initially, but then ultimately things have to be set right, whether it's the, if some investment is required. So that is what I said. It's not the only 18 months milestones that one has to look at. It's the entire life cycle. It's a marriage, not just having tea and coffee for some occasional time. So that has to be factored, and if too much corners are cut at the tendering phase, I can assure you that there are going to be problems, and this evolution of standards, revision of protocols is a global phenomena, and it happens. Everybody is learning, we are also learning, and things would change, they are bound to change. And we can't say that this is the set of standards today and it's carved in stone and nothing would change forever. Today some standard is written, tomorrow there would be a revision, there would be some fine tuning, because the fact of life, what we experience, we have to align, we have to keep the grid running, and there even small power interruption these days, it's simply not acceptable. And the kind of grid that we have, it's the single largest synchronous national grid in the world. It's not a joke. And it's all vulnerable. And the development in our case is not distributed as in case of, say, Europe. It's all concentrated in one pocket. And we had several of those events. And in fact, the records are there. We have been very forthrightly sharing. We are taking everyone along. We are trying to engage as much as possible and communicate the requirements. So if anything has to be done, whether it is retrofitting or whatever, it has to be done. I take the example from the German case, the 50.2 hertz problem. Okay, the rooftop solar was there, but then ultimately they found a problem, they recognized it, they accepted it, and did something to resolve that problem. So that approach has to be there. So it's collaboration, sir, not confrontation.
Yeah, thanks, Mr. Vivek. So, that's very correct that, these regulations will be evolving as we, move forward with integration of renewables. For example, grid code regulations for renewables came somewhere in late 1980s in a structured form in Germany and Denmark. And since then, these revisions, changes in the grid code regulations has been happening across the world, and we are that experiencing in India also. And as we move forward with higher and higher penetration of renewables, there is certainly going to be the need for revisiting those requirements, because eventually if we are, targeting the grid, which is predominantly going to be dependent on the renewables, so renewables are expected to actually take the responsibility of what conventional power plants have been taking up. But of course there has to be a adequate balance struck, taking into the consideration the interests of different stakeholders as we develop and progress in this journey of renewable energy integration. I would now like to open up for a few questions from the audience. So if there are any. This one, yeah, first. Your name and organization you are coming from.
I'm Rohit. I'm from a technical consulting organization called 𝗏𝗏𝗏𝗏, primarily doing the tech power system studies. So my question is focused around is there any way forward, or is there any thought in the direction of standardizing certain things, especially with respect to the inadvertent HVRT and LVRT tripping, which is actually happening? Because what is happening in the models would be simulated, and the overall planned model would be simulated with a K factor. But what happens is, in the field, there could be different OEMs. It could be a combination of solar and wind and battery energy storage, and the distance from the POI could even range from simple 5 kilometers to even 80 kilometers. So the difference in voltage level from the POI to the source, RE source, could be significantly high, and that itself can trigger an inadvertent tripping. So at the moment, we are doing the fine tuning and we are trying to provide some zone based approach based on the voltage levels and probably different models having different approach towards finalizing. I mean the fine tuning is happening that way and it's more to do with the hit and trial approach. So any thoughts on how we can standardize this? And also given the fact that it's very much challenging to actually conduct field tests because it's not possible to create a three-phase fault and check for LVRT in the grid. So that's also a thought. So that's my question. Yeah. Thank you.
Thank you. I think before I would request Vivek ji to answer this question, I'll just put my comments on what you are mentioning. See, this is across the world. It has been well established. The compliance has to be done at the point of interconnection. Now, of course, the plant will have the interconnecting line from the plant location to the POI. So it is, in my opinion, the responsibility of the power plant actually to take into consideration the drop that is going to be there in the this power evacuation line, which is connecting the plant with the point of interconnection, and then accordingly design its strategy for LVRT or HVRT. Considering the point of compliance being the point of interconnection. So you have the measurements maybe locally available in the plant. Now there are different ways you can indirectly calculate the measurement or the values at the point of interconnection and give them as the feedback to your power plant controller and others. But I don't think there is, in my opinion, need and it should be standardized how to actually do this. That should be left to the plant because they know the better. They have different devices from different OEMs and they should be given that flexibility how they comply with this regulation at the point of interconnection, because standardization, it has its own plus and minus. When you standardize, it is restricting the flexibility of the plant in this case. So in my opinion, that flexibility should be retained there, but point of interconnection should be the point where the entire control philosophy should be, designed at. I think, Vivek ji, you will be, in a better position to throw some more light on this.
No, that's perfectly, sir. Nothing beyond what you have said. It has to be the plant owner who has to find out the way how you meet those requirements at the point of interconnection. The solutions can be many and diverse, and it would depend from the kind of the equipment that you have in your plant. So nothing more. It's very difficult to really standardize. The only requirement is that you need to stay put and ride through the fault, whether it's the low voltage event or it's the high voltage event. You have to ride through the fault, and whatever is required to ride through, that's your take and how you achieve that. So in doing so, if the inputs are required from the grid operators, from the planners, please approach, whether it's the topology requirement, whether you want to have inputs regarding short circuit ratio, or whether you want to have some information about the neighboring power plants. So all that information can always be shared. It is being shared. So please don't hesitate. Please approach. We'll provide you whatever inputs we have to help you in achieving those requirements.
Next question. You want? Yeah, you can, please.
I think it's standards are good giving frames, but here we talk about not standards. Here we talk about responsibility at a certain point. And then the interference. Do I want to know X, Y, Z? It's clear. At the point of interconnection, the responsibility lies with the developer or owner or who else it is. It's clear. He has his requirements. We need to give power as a right quality and manage the behaviors. Done. Very clear. The tools to do so, simulation, modeling, fine-tuning, existing. Yeah? And if it's wind farm, if it's solar farm, now we come battery. You saw the examples of Statcom. We have hybrid plants going on and so on. So it is a matter of clear responsibility, yeah, at a certain point. All good. Yeah, that's what I mean. And then the more challenging part is we need the skill sets to do the work. Modeling is not just plugging in something. Yeah, so it's huge knowledge which you have to build up, and you as a consultant or whatever knows it. And that goes down to the single inverter at the end of 50 kilometers or whatever, or wind turbine or what. Yeah, so it's the knowledge, and I think that's a good forum here. Yeah, it's knowledge and clear responsibilities or accountabilities, let's say it this way. Yeah.
No, just one liner. Because from a developer point of view, we are totally dependent on our modelers and consultants like you, right? And so whatever you suggest, whatever simulation, fine-tuning, and because and now when we see that we are facing a lot of issues around it, we have started doing some simulation modeling in-house also. So we just started within my company, Renew. And for 1-2 projects we have started doing in-house. And sir, this area, like, modeling, simulation, and it's something which is very few consultants are there in the market. And it becomes very, very challenging for people like us, because when we wanted to get it done within a span of a month or so, all of them are totally booked, right? And we have to do the commissioning faster, right? And so we just act as a bridge between
grid authority,
grid authorities and the modelers. So we don't know, right? And if you ask me that I want a full switching model of WTG, as a developer, I don't know what is this full switching model. So I will go to my OEM.
Yeah, that's a good part. Now interaction starts. Now good. You buy Suzlon turbines, you get the model.
Right. So
very simple. You get even the plant. Very simple. You select others, you have problems.
No,
joke aside. No, this is what I said. It's about knowledge.
It's
about knowledge.
You are right. No.
Yeah, joke beside. Yeah, we, as I mentioned, we have the luxury who dealt that with in other countries, now, and we have the capabilities, and they are rare. These genius guys. Yeah. So, but that's a differentiator. What we said, we need to look at plant level, work with developer, and specifically with grid. Yeah, and then there are guys who can do it, and there are guys who not can do it, and that's you'll find out. No,
you are absolutely right. But we are getting into that level once everything is already deployed, right?
Yeah,
right. So and we will learn through the process, and it's a collaboration, right? But mostly in this collaboration, the developers are at the receiving end, right? We have to run from the pillars to post, right?
Making the biggest money. So other side. now inside. That's for the coffee break.
So no, I can understand. So let us conclude this question. There is next question over there.
Yeah. Rahul Agarwal from Neon Systems. So Mr. Pandey, you have not been speaking on this particular last question. So this question is exactly to you. Like when we are looking at all those specific problems that you talked about, they are typically that I'm seeing, the controller has got a big role to play in the modeling thing. And lately we have been trying to do all this modeling thing like what Mr. 𝗏𝗏 talked about. And the thing is that, when it comes to specifications or the guidelines, the FTCs, they talk about generic model. If I have to make my controller more efficient, I would like to control it in my fashion. So it has to be typically, as I say, a user-defined model. But what I understand with the accredited agencies that we try to get in touch with, like what Mr. 𝗏𝗏 talked about, they said, no. Give us only the generic model, and that's how the system would work. And then there are certain guidelines with respect to the tools with which this model has to be prepared. What are the grid operator's view on that? Because unless and until you give that variability to the user or to the developer or to the designer, that innovation and that, the flexibility probably will not come. We will continue to do what we have been doing, and probably that's how the grid will continue to operate. Thank you.
Yeah, thank you for raising that issue. It's not only the generic model that we are asking, we are also asking detailed plant level models. Okay, so it's there. The generic we are asking because we need to simulate the entire grid. We have to plug in your equipment into the grid model just to see the grid behavior and stability studies and all that. Okay, but we are also asking for the detailed models. Then coming to the again the software in which we are asking the models. See, it would be really very challenging to maintain the all India. It's a very big model, and it would be very challenging if X developer submits in some platform and Y it submits in some other platform, managing the whole thing, converting, and then again the developer would say, no, since you have converted it into some other, it wouldn't behave the way it is actually behaving. So world over, all the operators, that's how we are publicizing that in advance, that this is the version, this is the platform in which we would like. You can do studies in whatever platform you are comfortable with, but kindly share, convert it into the form in which we can integrate and do the integration studies and operation studies. That's the, I think, global practice.
Yeah, so I think I'll add, a few more points to this. As far as this modeling is concerned, even in generic models, you can have user-defined models integrated through the generic models as well. So you can have your user-defined model from the OEM, and that can be integrated with the generic model, and that can be provided. But there can be a generic model also itself that can be provided. So as such, I don't think, in my opinion, and based on my experience, there is any specific restriction that it has to be exclusively generic model. Generic model, as I said, generic model, behind the generic model, let us say WEC models are there. Behind that, you can have user-defined models. So grid operator will interact with the generic model, but within the generic model, you are actually behind that is your OEM specific model. Now, coming to the platforms, I understand what you are pointing out, that there are different tools that you might be doing, and stakeholders from whom you are getting modeling might be actually working in different platforms depending on which country they are primarily based in and which country their business is primarily based in. Globally, this is the practice that the grid operator and the grid authorities specify these, these are the tools in which you will have to provide the modelers. Almost all countries which are having this RE at a higher level, they do specify the tools and platforms through which those models actually have to be given, be it EMT, RMS, switch model or whatever. They have to be provided in those specific platforms. There is one country, though I am fully aware of, France, where the respective grid authority does not ask you to provide the model in specific platform. They actually develop your model. They of course take your inputs and the model in different tools that you would have developed, and then they develop their own model in their own software of your plant, and then integrate that in their system. But that is one of the example and outlier in my opinion. But vast majority of the countries, for various reasons, I mean, the grid operator also cannot have n number of tools. It has to also identify one specific number of tools that it has to build its own expertise, and then integrate these models from different plants that are coming in from different regions of the country. So there are those practical constraints with respect to what should be the tools around which the model is developed. That's in my opinion, that is the reason that there are these specific tools specified by different countries for these modeling requirements. There are so many hands up. I don't know how many questions we can take. Maybe we can take one question from here.
I am from Adani New Industries Limited. And my question here is on the pass-fail criteria for the simulation model on the benchmarking reports, as well as on the test results. So sometimes what happens, I have say synthetic inertia, right? So I have increase the power, and after the power boost up, it goes slightly down. So there are certain occasions where we have a point of discussion that it should not go that much down. Now the question is, when we do test in the field, we don't know how much, whether it will be accepted or not accepted. So sometimes there is a confusion, if I don't have any pass-fail criteria, okay, the 10% down is acceptable. Say after the FRT event, I have the oscillations, and oscillations settling down after say 5 seconds or 10 seconds, or there is the amplitude of the oscillations. Those pass-fail criteria are not defined yet. So I think that is one challenge what we see as an OEM while doing the test in the field. So that is uncertain, whether it is accepted or not accepted. Sometimes there is unclarity in the reports and the models what we used to have in the benchmarking reports. So I think one thing I would like to know your comments on this.
Vivek ji.
Yeah, certainly this has been identified, and in our interactions with developers, this is one. How do you evaluate the performance of the simulation model? So those benchmarks and those metrics, presently they are not very, very explicitly laid out. So this, we are already in discussion with Central Electricity Authority, and probably they would be coming out with the draft regulation, some amendments in the technical standards, which maybe probably will specify these.
Yeah, so these are, those response rise time, settling time, overshoot, undershoot criteria, as Vivek ji rightly mentioned it. Though it's not very much, clearly specified as of now, but I'm sure that is, going to come in the future requirements and the clarification and the regulations that hopefully will come out. So that should address your concern. Thanks. Only one more question we can take before we move to over there. Please.
I'm Manas Vijayan. I am working at Council on Energy, Environment and Water. We are a think tank and policy research institution, and we are currently focused on increasing the penetration of rooftop solar panels right now in Uttarakhand. My question is, with knowing that we have uncertainties in predicting the renewable generation, and with the intermittency in generation as well, should we be focusing our research on predicting the generation side, or should we focus more on forecasting the demand side from consumers? What will be more beneficial for addressing the challenges of grid integration of renewables?
Yeah, let me try and answer by giving you an example, an own example. So I'm the luxury to have a big family, and a luxury to live in a place where we have sun, wind, and my wife asked for an e-car. So I live in a place where I have installed, and connected to the grid. So giving you an example, and have a heating system. In Germany it's cold sometimes, a heating system and a heat boiler system which use the air in the room. So recuperation thing. So I have a solar panels on my roof. I have a wind turbine in my backyard, a little bit far away. Yeah, I have 2 e-cars and a normal car, because if I want to drive a little bit longer distance to Italy to go skiing, this is this requirements set. And I have 2 meters, smart meters, net meters in my home. And I need backup power, because I have events where my wind turbine doesn't produce and my solar panels doesn't produce, but my wife wants to go shopping. So I have a computer in my home which manage the demand, the washing machine, the all this stuff, heating and so on. And I can predict my forecasts because I know when my wife comes home, I know when I'm coming not home and being in India, and when my bigger family of 10 people use their waters and washing and so. So it is, you rightly said, it is about forecasting, knowing your demand side, and sometimes saying, now you don't get power for this and that. So this is, we call smart home or whatever you say. But fundamentally, I need backup power from my colleagues from the grid. Even I can optimize forecasts and so on. In a small environment, you can believe, 10 parties, different sources and so on. Weather forecast, sky camera I have. So I can, and I'm a little bit technically driven, I can say there is a cloud. It comes over my panels. You have not, in the next seconds, half an hour you don't have. And then you need to scale. And that needs really computing power, understanding of forecasting, accuracy, and so on. So this is in the small ecosystem of that, it's scaled. But it's doable these days. I can tell you, doable. But we need to learn. And it's much more complex, much more bigger power comes in, when we talk about India grid, when we talk about states, when we talk about interconnections. But it's doable, I can tell you. The easy part in my case is, I'm the orchestra. I need to debate with my wife, to have enough power for the certain things. But that's the stakeholders, that's the understanding, and I'm interacting with the parties in my family about when can I do what. Easy. You have it at home. Or I have the luxury to have it at home and can play a little bit around. So maybe that answers a little bit in a nice fashion. That's doable. Smart meters, all done. You have to understand the technology which is available today. Transfer it in a techno-commercial solution for India. That's the key.
Just to supplement, it's not just the electrical parameters that we need to forecast. We'll have to also see particularly, as he also mentioned, the human behavior side. So we have these examples and several experiences of solar eclipse in India. The way the demand response to a solar eclipse in India is altogether different in the way the other countries respond. So the local practices, the local traditions, the human behavior, all that has to be understood to be really able to forecast the demand and the requirements.
That's a tough job, I can tell you. Tough job.
Yes.
Even on that level, I can tell you.
Forecasting, now, as yesterday also I was mentioning, I think, and some other speakers, we have been, driving the entire grid traditionally around the load, which has been variable and intermittent in nature, and now we have the variability and intermittency from the generation side as well. That makes it more challenging. So with that, I would like to come back to Mr. 𝗏𝗏. So you already mentioned it some, why is it the concerns of RE developers? But at the same time, RE developers are, one of the key stakeholders in integration of renewables, and there are more and more expectations of RE developers to help the grid in, seamless integration of renewables. And for the fact we are going to have, that is the universal phenomenon, we are going to have revised more and more stringent, strict regulations, which is already happening. And as we move forward, that, it's going to be further tightened at higher penetration of renewables. So what do you think from the RE developers' perspective? How do you brace for, these grid regulations, grid compliances, which of course are going to evolve further and further as we move forward in this journey? And how do you see RE developers being in a critical role in this entire spectrum, playing a constructive role in integrating these renewables into the grid?
So the question is very genuine, sir. I represent Renew, and we have around 11 gigawatts of operating plants in the country. Okay, and whenever I go with such request of getting on our modeling or all that stuff with the stakeholders, they say that, boss, now you are the master of the field, right? And you should know, you should teach people, other developers who are kind of trying to get into this field. The challenge, 2-3 challenges which are very obvious and which we need to do internally also, means our house that way is also not in a very nice shape, in the sense that the in-house competency that as a developer I need to have internally, that is also lacking a bit, right? As I said you that when we were totally dependent on modeling to third-party vendors or third-party consultants, and when we saw that we were struggling over there, we started our in-house department for modeling, and we are trying to explore, right? And that is something that we are, we have started hiring PhDs and all, and they are working on it. So that's something that we are strengthening internally, and that's something which all the developers will have to do, right? Because that's a big pain area, right? That's number one. Second is like whatever you ask, right? You ask moons and stars, we are there for it, but you will have to pay for it, right? You don't ask something for free, right? But I have commissioned a plant in Rajasthan just 15 days back, and I'm getting a tariff of 2 rupees 18 paisa, right? And if you want me to go for SVG and all kinds of capacitor bank and all kinds of embellishment that you want me, there's a money, right? You have to pay me for that, right? And there has to be some economics. I can do it for 1 plant or 2 plants, but if I'm having around 50 plants in the country, that I cannot do everywhere, right? And that too, when these regulations are getting formulated, I am also Secretary of the Wind Association of India, Wind Independent Power Association, and the pain is too severe. And unless we have huge capacity addition program, we talk very proudly about 500 gigawatt capacity addition. Unless until these issues that we have, grid connectivity is one part of it, are looked into, that's going to be very, very challenging. Because in wind, right, means that renewable journey in the country started with wind. Right now, at this point of time, we are precisely at the number of 47.9 gigawatt in the country. And the whole ecosystem is anxiously waiting to hit the half century. So we have been given the task that immediately we have to reach 50 gigawatts so that we can celebrate as a nation, right? Even the solar, we are waiting to reach 100 gigawatts, right? So those kind of milestones are there. And internally, we are building in-house capability to handle it. Even minor equipments here and there, tweakings here and there, they should be, we don't mind spending for it, but large hit, if we come through some regulation, that should be adequately compensated. And at the same time, the collaboration between Grid India, CTU, and the developer, right, that has to enhance, okay? Because some of the stuff like the connectivity, modeling and all, I'll go to CTU, they will say that, okay, you talk to RLDC, right? Then RLDC, you talk to CTU. So I'll keep on, shuffling from one place to another, but they will not talk to them. They will not talk to each other, right? So that creates the problem for me. So I get a bit of leeway primarily because of my, with being from Power Grid. So I can collaborate both of them to talk and, get my issues resolved. But sometimes developer in general face these issues. And they will have to work collaboratively and see their role as a facilitator, right? They have to get things done. And if it's not getting done, what can we do? Let you guide us, right? A lot of us are new platforms which are coming into these sectors. They are totally novice in this field. They don't know It's complete, grid connectivity is a black box for them. They need good people who can guide them, who can handhold them. So that's something. But things are going to improve in the days to come. That is for sure.
Thank you. I can understand RE developer as an RE developer. You have to, coordinate with different OEMs of be it wind turbine generators or solar PV inverters, PPC, OEM, other equipment OEMs, and then the grid operator. And then there are, commercial implications that you mentioned. And I'm glad that, you are also conscious and you are already taking the, measures to strengthen your, in-house expertise and capabilities for these grid compliances that are there and are going to be revisited from time to time, and that's what is required. The RE developers need to actually be prepared for those changes, and of course I fully agree that the commercials and other economic sides of that need to be taken into consideration while those regulations are framed. Taking forward from their follow up on this, Vivek ji, what in your opinion the grid operator needs to do further to what Mr. Ch0ʔ was telling, facilitate this further renewable energy integration in a more constructive and collaborative manner? So in your opinion, what further can be done from the grid operator side?
Yeah, as Mr. Ch0ʔ has said, collaboration part, certainly that's we recognize that, and we are always open and working towards increasing that interaction. And I don't know the case where you are mentioning about shuttling between CTU and Grid India. Of course, I can discuss with you off stage. That should actually not happen, and we try that at the connectivity phase. If there are issues, it's the same. CTU also runs those models, we also run those models, and our observations and their observations, they go together. So that's one part of it. For going ahead, we are, sir, always trying to share our observations, the grid events, whatever, publicly, monthly now. It's a monthly interaction that is scheduled at the regional level. At the national level also, every 1.5 months we invite developers. Only I'll suggest and request to depute the right persons, because the meetings and interactions that we conduct, they are not for administrative discussions. They are pure technical discussions. So if such people could be deputed from the developers, then it will help a lot. Then on the grid side, we are working right now with IMD, and IIT Bombay is taking a lead. We have just instituted a R&D project for improving the renewable energy forecast, because that's one pain point, as Mr. Ch0ʔ has also mentioned, about the deviations and the implications, charges for deviation. So the forecasting has to improve. So the government is conscious. We are also supporting the government in that, and working very, very aggressively and closely with the competent experts in that area. Then ancillary, as I highlighted in the presentation for frequency regulation, we are encouraging participation of more and more generators at the intrastate level who could increase the fleet which is responsive to frequency and supporting the grid. Then on voltage control side, some time back we submitted a full detailed report for voltage control ancillary services. So we are continuously pursuing and in dialogue with the regulator to introduce commercial mechanisms so that the inherent capabilities that are there in the RE plants, they could be harnessed. And then of course we can also optimize on installation of equipments for voltage control. I think a lot of activities are happening, and simulation models, certainly that is one area where as a country we need to really work together and keep emphasizing. And please, let's come out of this idea. Let's not be too emphasizing that 18 months is the commissioning schedule. No, it's the entire life cycle, and it will involve continuous engagement and changing in the models and everything. So a lot of work is to be done. Certainly, we accept that, and we are working to it and fully committed to it.
Thank you, Vivek, for your ensuring words. Moving forward, Mr. Bernhard. So technology is, evolving every time in every stage of the life. The civilization, technology has been evolving, and that's true with the renewables also. And one of the technology developments that is emerging is this grid forming technology in the RE sector. At Suzlon, how do you see this grid forming based technology in terms of wind turbine generators, evolving globally, and to what extent Suzlon is actually having the plans for this grid forming technology, and how do you foresee that this technology entering into the RE market as we move forward globally, and of course you can give some perspective from the Indian market as well.
Yeah, I think as grid forming, grid supporting technologies in general, I would put it this is technology-wise inertia. No? It's about inertia. Yeah, and I think we are on a very good way in the industry on that. And when we see wind turbines, and I'm focusing now, when we currently see the technologies and the requirements on your side from a frequency side, plus minus 10%, yeah, I think we meet that. Yeah? The question, the aspects is I think what we touched here also, don't see the generator of a wind turbine like a full-blown power plant. It is the wind plant. It's a POI. Yeah? It's really the wind power plant or hybrid power plant or whatever. I think that's more allowed the scope what you look at and how. And then talking about on this substation level or wind farm level about STATCOMs, yeah, active or passive elements. I mean, we talked about that's a technology which is existing. It's now a matter of how commercially it fits into the whole scheme. Yeah, do I get paid for or not? Yeah. And as I mentioned earlier, there are some smarts. If you understand your plant, the behavior of your plant, of turbines, of the elements, if you design the feeder lines properly and so on, yeah, then you can do already a lot with serving the grid, yeah, with the existing technologies. I have to say, yeah. Then when you talk about storage technologies supporting, a lot is discussed with batteries. It's not my favorite, but it's a given here, and that also will help. Yeah, and just a little bit more details is a fundamental question, of course, when you look at the individual wind farm, which the size will increase over the time. Yeah, we're not talking about 1 megawatt anymore. We are at 3 megawatt, 5 megawatts from some of our OEMs scholars betting on this. Yeah, more. So the impact, if you lose one turbine on a 200 megawatt plant, is big. So you need to manage also within the wind farm. Don't underestimate. And then I can also understand that somebody looking from outside want to understand and get data from the individual turbines because they're getting bigger. So it is a fundamental thing of what technology, defect, full converter I apply, but it's more about utilizing what we have today with a modern, I come back, simulation, engineering tools. It is about this. The requirements we have is clear. 5 ± 5 frequency, which works. Other fault rights rule, etc. It's given. Yeah, I don't need any, from an OEM perspective, I don't need any more requirements. It's clear. Technically wise, it's clear. Now, how different the solution provider, I call it, or wind turbine or solar provides the solution. And of course demonstrate that. Yeah, some we can, some we cannot. Yeah, but it is really about a proper design engineering job to be done, because you know it, most of us know it. We are not alone on the way. We need to find our way in India, but it's existing technology available.
Yeah. Thank you. Thanks for your comments, Mr. Bernhard. We are already running out of time, but I would like to open up for a couple of questions from the audience. Can you give mic to Suniji? Yeah.
Yeah, thank you very much for giving me this opportunity. It's not really a question. I was just listening. The issue is connectivity, the pains of a developer, the pains of a technology, and then in between the sandwich grid operator, and here is the academia. So the issue is like this. I'll take 2-3 minutes to give my perception, how should one look at it. So, a decade ago, when we first came up, that there has to be some connectivity tests and some documents, as usual, the matter got escalated. We have Chowbejis who will raise it to minister level, and then I was hauled up. And all the bureaucrats and politicians were asking me, why do you need all these things? These were not there. What is it that you need? And you can't explain through HRT, LVRT, and all those models. It doesn't work. So we sat all along and thought over it. I found one analogy which works. So I am just sharing this. I am taking the liberty of sharing. Basically, grid is nothing but society. We want peace, harmony in society. And if one person gets wrong in the society, it can cause chaos to the society. But people will come, and still the rules and regulations have to be there. So now quickly switching over to one experience. If you want to use influence, there are many ways to use your influence, and one should also, and one works also. 2 places where I have found influence doesn't work in the society. Number 1, taxation. When it comes to taxation, most of the bureaucrats and politicians will withdraw. No, you please sort it out. I can't do anything. And second, where it is? It is in immigration. Immigration check, I realized, nobody wants to interfere because it's a matter of security of the society. And one person wrong is enough to do damage to you. And all of us have gone through the visas and immigration checks. And every time, sometimes somebody asks 5 years of my IT statement. I said, what the hell I am? Why should I declare? But this is how the rule is. Rule gets changed. So I went and explained this to the minister, the then minister, 1-to-1. Sir, would you interfere with that? You will not. We want people to come in, we want new generators to come in, but then society has to be orderly run. Otherwise, one wrong generator is enough to damage the entire. We are not doubting on the technology or the developer's intent, but then everybody is not angel. We have rogue players, and one rogue power plant can damage the entire reputation of the entire society and cause damage to every generator. This is what is to be understood. I think you look at it, technology is one side. We know all this. But look at it from the societal side. That if you are not following, so one more example and then I'll stop. There was one generator which was getting commissioned with a 230-kilometer long line, and there was a series compensation to be put. It was not put. So he said, I am ready. Why am I not being allowed? Again, matter went up to high. I said, sir, if he is not putting this, there is a chance of a subsynchronous resonance on this generator. So that's why we are holding it. He had all the lawyers and insurance company in that meeting. He said, sir, it is my generator. If it gets damaged, how is the grid operator concerned? I will bear the cost. Why should he? Again, counter question to me, why are you worried about it? So I had taken all the books where a rotor had gone to the roof and damaged the whole thing. I said, sir, he can afford to absorb the damage of the generator. But as a grid operator and as secretary, you cannot absorb the damage to the whole country that they allowed such a generator to be connected, and today such losses have happened. So I would request this technical audience to look at it from the societal side. It is for the good of the grid. And then gradually the culture will come and everybody will improve. Thank you very much for allowing me to explain this in the long way. Thank you.
Thank you, Suniji. Thank you. You wanted some question earlier. Sorry, we could not.
Good afternoon to the panelist. I am Panda, Secretary from Madhya Pradesh CRC. I just wanted to have a basic question, how the grid is designed actually. Suppose state-wise increase in plan is there, or what is the basis of growth expansion of grid? In a simple statistical terms, you can say like 5%, 10% for each state, or across the country it is designed as a whole one.
Yeah, thank you for that question. It's very, very relevant, sir. Our country is very diverse and the growth numbers are different for different states, and in fact, look at the district-wise, you'd be aware, it's all different. So, the Central Electricity Authority, it is assigned with the task of projecting. So, electric power survey is conducted. So, they do it through an econometric method, conduct surveys through of different sectors and project the likely demand for different states and then aggregated demand for the entire country. So that becomes an input for the industry, that becomes an input for the transmission planners, that becomes an input for the generation utilities to plan for their investment. But this all, the infrastructure transmission or the infrastructure planning is required to be done in a coordinated manner, because ours is a federal structure. We have state transmission utilities who have this mandate to develop the transmission network within the state, and then we have the central transmission utility which has the mandate to coordinate the transmission development for the interstate network, so connecting from one state to the other and looking at the nation as the whole, because the resources are spread out across the country. Earlier we had a philosophy of looking at self-sufficiency within the state, and then we moved to self-sufficiency within the region. But now the philosophy is to optimize and harness the resources across India. So at the lot of things are being planned at the national level. So we have a National Committee for Transmission Planning. So wherein the proposals from the state transmission utility or from the central transmission utility, they are put up before a committee of experts who examine those proposals, and then those proposals are then deliberated technically that, okay, this is, these project needs to be taken up, and then those projects are bid out. So it's the transmission projects are bid out. Generation, sir, is de-licensed, so whether it's, and a lot of growth is happening because of that de-licensing. So the entire RE capacity addition is through private sector, and of course we have public sector utilities also, generation companies, which take up generation projects at identified potential sites. For example, if a thermal plant has to come up, then it makes economic sense if they are located near the pit head, so that the coal movement and everything is economized. But then, of course, electrically and technically, at times we need some generation to come up closer to the place where there is consumption, because we have the stability, technical stability challenges, the voltage support is required. So it's a kind of a very fine balance that has to be done. And so it's all, as operators, we continuously provide the operational feedback. We are mandated to provide it quarterly. It's published on our website. Very rigorous, very exhaustive, 400, 500 page feedback is given. That is taken up, examined and looked at by the planners, and then we also continuously publish some reports to assist policy makers and administrators to and wherever we get an opportunity, we certainly present our inputs so that it helps in the right direction when it comes to policy making and planning, sir. That's how it's done.
Thank you, Mr. Vivek. One last question. Sorry, we are quite running over there. I'm sorry, there are so many questions, but because of the time constraint, but maybe in the networking session after this, session is over, you can take up. Please.
Good morning. Vinod from 𝗏𝗏𝗪𝗏 Limited. My question is with Mr. Vivek because he was also instrumental in streamlining the primary ancillary service for the Western region. So my question is that we are seeing the frequency is oscillating. When we see the profile of the frequency, so we see that when it is going down and then it is coming up and then shooting up and then it is going down. And it is taking long time to come within the band. So what is the role of the thermal plants in this case, because we have the primary ancillary in place? So are there any challenges regarding that? And why primary ancillary services are not being incentivized? So this is my question.
Yeah, so our 70% of our capacity is thermal. So that makes it really a unique case where we are having this secondary control predominantly based on the thermal. Coming to your primary response, it's mandated in the grid code right from 2010. It's there, and that's how in between CRC gave an order to conduct the testing of all the governors. So we conducted more than 240 units were tested, and there has been a lot of improvement in the primary response that we get for those events. So primary response is there, and that's how we have been sailing through various contingencies. And right now our reference contingency, which earlier used to be 4,500 megawatt, considering the largest power plant size of 4,500 in Vindhyachal and in the Mundra complex. So that was the reference contingency. But with this concentrated RE, we have had events where we lost more than 6,000, and in one occasion we lost 7,000 megawatt. Of course, it's very challenging because the declining inertia, the nadir frequency goes very close to the UFR stage 1, and one or two occasions we had experienced under frequency based load shedding because frequency went below 49.4, that's stage 1. So grid code also has the 2023 grid code that was revised in October, that has also mandated, and grid code also mandated frequency response from the RE plants now. So we are working, and that's what I showed. One pilot we did with one of the solar plants. We'll like to do with other wind also in one case, and we'll then try to work with the regulator and see that some commercial mechanism is there so that adequate remuneration is there to encourage participation. Coming to incentivization of primary response, recently in the terms and condition of tariff, CRC brought out in April 24, they have provided an incentive for the plants which would be contributing. So there is a detailed methodology how the frequency response would be evaluated, and then there are incentives related to that. It's there.
Thank you, Vivek. I think we should now wrap up. I would request all the panelists to, give a brief final remark, 30 seconds to maximum 1 minute, what, in your opinion, should be the way forward for this journey of integrating renewables?
No, I keep my answer to the wind business and plant, and that is, I strongly believe in that technology solutions will contribute when we collaborate. So that's the way forward, and it is about knowledge and willingness. And then, of course, the commercial comes, all good. But it is about knowledge. I have to understand what, and it sounds easy, but it is about, and technical solutions we will find together. The grid is the backbone of our nations in regards of electric power. We need to understand, accept that as the players around. We want to get electricity at our house. The farmer needs it. The big plants needs it. So it's a backbone of the economy, beside others. And therefore, I think it's important to have this kind of forums. The journey is there. Different interests come together. Yeah, and with smart guys and girls, we can do it.
Thank you. Vivek ji.
Yeah, a lot of it has been already said. Two things, collaboration, certainly. We would like to have more and more research going for the problems that we are facing. And they are far too many. We may not know how to define that problem, and that's where the researchers have to be slightly, they should reach out to and then figure out how this, and to the industry also, certainly we'll have to work together. One aspect which I missed, I'll take this opportunity, the visibility part we have probably not discussed. So that is also very important, the better visibility of these generation, whether we talk of phasor measurement, installing those PMUs in the site, or for the rooftop solar also. That's the challenge. How do we figure out what would be the generation? So we need to do some homework, and cyber security part, that's a big threat looming out. So let's be honest, and work towards what they say, customer delight. It may not be asked for, but let's work to the best as we can.
Thank you. 𝗏𝗏 ji, Mr.
In fact, the road ahead, the task ahead is mammoth. The huge capacity addition that is planned, that is being talked about, and the responsibility of deploying that is primarily on the private sector. We are totally cognizant of this fact. In fact, as a company, we have a portfolio currently running around 11 gigawatts, but we have a portfolio of around 21 gigawatts. And so there are a lot of new things that we brought to the country, right? We deployed the first RTC plant in the country. We deployed the first assured peak power, where at single location we have solar, wind, battery, 150 megawatt hour battery. Then we brought first RE merchant power plant in the country without any off-taker. We brought a JV with Fluence in storage, understanding that storage is going to play a very important role. We signed virtual PPA. So all those things are evolving. Primarily challenges, like when we were doing plain vanilla solar and wind, things were not that complex. Now when things are, it's a multiple source and all that, then the modeling and all those aspects have become very, very complex. And then a bit of frustration comes out, because in the process, somebody has to bear the burn, right? But going forward, I think we, as developers, are also acclimatizing to it, right? And there is a lot of openness. I talked about Great India. I talked about. We feel very proud in having the transmission network and the way it has been operated. It's one of the largest and better managed network in the world globally, right? And it's a impeccable and great organization, means Power Grid, and because all these associations like Great India and or CTU, they're all offshoots of Power Grid only, right? So we have that sense of pride because of that, those kind of organizations. But at the same time, we need, being on the other side, we need more support from them, right? And that is something that is expected out of them, because we are endeavoring for newer things, and there the role of grid connect. Without grid and without connectivity, you are nowhere, right? So we need that kind of assurance that is there for us. Where if we try to do something new, that is that grid corporation or CTU is there, or Power Grid is there to handhold us and take us through that journey, right? So their role is going to be very important. Last comment, because I feel very proud in working for a company which is doing great job in climate change, right? So, and I like one quote from Barack Obama. He said that this is the first generation which have started feeling the heat or impact of climate change. And this is the last generation which can do something about it. So this is the time that we have to go for huge capacity addition, the energy transition that is paramount for the nation. And as a nation, we have taken the lead, and all of us are being a stakeholder into this, has to ensure that we achieve that target. Thank you.
Thank you, Mr. Chaubey, for the constructive remarks. I think if we want to summarize it in 3 words, the whole discussion, I think knowledge, collaboration, and cooperation should come together to help us in sailing through this journey of transformation of the grid. I would like to thank for your time and very interesting and knowledgeable information that you shared with the audience. I on the behalf of our organizing committee, thank for your expertise, for your time, for your inputs that you gave on a very much important and timely topic that we have in the country. Thank you so much for being here.